So basically today we have this thing called the Hinge Theorem, all right, which basically is going to describe the opposite side. All right. Now let me try to draw something up here for you to give a good explanation, and then you can kind of see. And the lesson is really short and it's really simple. But like I said, some people don't see things very well. So now I'm going to try to draw something, right? And I want you to try to watch what I'm drawing. And again, I like notability because it allows me to draw and create a few things. All right. So today we're going to discuss the Hinge Theorem. All right. And basically what the Hinge Theorem says, and see if you agree with this. The hinge, when you think of a hinge, you think of the hinge on the door, correct? So the hinge is what is creating the angle. Everybody with me? So when you open the hinge, all right, the door opens, correct? Now how silly does this sound? When you open the hinge wider, the side opposite the hinge is getting what? Getting bigger. Everybody with me? All right, it's kind of like what we did last week, but there's something that, like I said, when I first did this, I was going, this is common sense. All right, but common sense isn't common for everybody. So what I want to do is I want to try to show you exactly what they mean. All right, so try to look up for a second. And what I'm going to do is I am going to say, for example, this is a length of 5. And this is a length of 6. All right. And then what I'm going to do now is I'm going to duplicate this over here. And I'm just going to give this a degree measure, let's say 40 degrees. All right. Now, we know from that information that this is what's important. The 40 degrees determines the opposite side. All right, we talked a lot about that. So this angle from here to here creates that side. The 5 and the 6 have absolutely nothing to do with that third side. How far you open the hinge determines the length of that side. All right? So now what I'm going to try to do now is I'm going to try to draw the same exact length. I'm going to say this is 5, and I'm going to try to draw this 6. Now use your imagination and say that looks pretty good. Those are about the same. All right. Now I'm going to say this angle right here is 35 degrees. Now does everybody understand? The 5 and the 6 are exactly the same. Right? The angle has changed. Now again, this is what's to me when my geometry teacher told me this, I was like, well, I know that. You don't have to even tell me that. What is the relationship between this side and this side right here? What do you think?
Well, the bigger the angle, the bigger the side.
Exactly. Right, and there's a whole lesson on this. And I'm agreeing with you. But and I'm not kidding you. I'm saying the test coming up is about as easy as it's ever going to get. It's as easy as it's ever going to get, this test coming up. Because to me, everything in this chapter is common sense. And I think it's common sense because I can visualize everything. And all I'm trying to get you guys to do is practice the visualization. That's what I'm trying to get you to do. All right? So in this particular case, it was no problem for me to see that let's just call this AB, and let's call this XY. It's simple for me to say AB is greater than XY. It was just easy. All right? That to me was just common sense. All right? Now, again, that's basically what the Hinge Theorem says. All right? Now, there's also the converse, which would say this, though. Listen to the relationship, though, how they're going to describe it. There is a side, angle, side relationship. And there is a what? Side, angle, side relationship. Now, The only way this will hold true is if this number right here, listen carefully, if that is equal to that, and this is equal to this. Obviously, now, here's where the key comes in, all right? Obviously, that's not going to hold true if I do what? If I can take this side right here, watch what I do. If I take this and I extend it out here, now some kids had trouble last year. Okay, is AB now greater than XY? No, we can't say that. The reason why we can't say that is because our what? Side, angle, side is no longer true. Everybody hear me? So the angle can change, but the two sides must be what? They must be congruent in order for the Hinge theorem to be to apply. Everybody with me on this? Again, like I said, very simple lesson. Very, very simple lesson. The bigger the angle, the larger side that's created. Now, what makes it difficult in the pictures that they're going to demonstrate is that they're going to switch up the triangles. All right? They're going to have triangles upside down and backwards, and you just have to find the what? The side, angle, side. And two sides must always be congruent in order for the Hinge theorem to work. All right? So now what I want to do is I want to kind of go back to the original, go back up here, and let's just talk about it. All right? I think I summarized the Hinge theorem for you, so I think you're in pretty good shape. All right? So now I want to look at question number 1 here. Now, what can you say about MR and RP? If I've done a good job, this is going to be kind of easy. Tell me. MR is greater than RP. All right. Now, again, you must find the relationship between what? You must find the relationship between the two sides. Now, it's offering PN is congruent to MN, and then we would say what? RN is congruent to itself, so now it holds true. All right? Because this angle is larger than this angle, MR is greater than RP. I'm telling you, that's how simple. Very simple. All right? It's really easy. So let's take a look at number 2. All right? Same principle here. We're going to go ahead and say AD is what? Greater than. Very simple. Again, we're finding the side angle side. And because two sides are congruent and one angle is larger than the other, that means that AD must be greater than CD. All right, so let's look over here. Hopefully it gets harder. All right, in this particular case, what can we say about angle C and angle Z? Reagan, what do we got?
Okay. So you have to find the angle, right?
Yep. We're looking at this angle right here and this angle right here. What has to be true?
Angle Z is bigger than angle C.
Exactly correct. And again, I'm just trying to stress, because this has to be true, that what? 24 is congruent to 24 and 30 is congruent to 30. All right, honestly, guys, that's how simple that is. All right, so let's just carry on. Let's go to number 4. All right. So now I'm going to highlight X, Y, W. X, Y, W is right here. And then I'm going to highlight W, Y, Z. Right there. All right. Now, I even tell kids on the test, when you take the test, sometimes you may forget. But if everything looks true, you should be able to say, just based off observation, what is true. All right, does everybody understand what I'm saying? All right, you don't need the Hinge theorem to tell you that, in other words. All right, but we know that X, Y, W is what? Less than. Very, very, very simple. Very simple. All right, let's check out 5. All right, so what has to be true here? All right, what has to be true about, and let's look at, I'm going to call this right now. I want to make it a side, A, B, C. So first thing, I'd like somebody to tell me what is true. Tell me what's true. 115, that's right. That's the first thing you know. 120 is greater than 115. Now, does the Hinge theorem work with this? Yes, and it works, again, just emphasizing, it works because those are both 24, and then this is congruent to itself. So the Hinge theorem works. All right? So now we're trying to figure out, what could X be? What could X be? I'm listening. Go ahead. No, in other words, write the relationship is what I'm trying to say. And then we're going to solve for X. Tell them.
So 4x minus 10 is equal to, is greater than 40.
That's exactly right. So I want everybody to write 4x minus 10 is greater than 40. Notice it can't be equal to 40. It has to be what? Greater than 40. All right, is everybody with me on that? All right. So now when we solve that, what do we get? X is greater than what?
1.
I don't know how you got that. Somebody please help him. 4x minus 10 is greater than 40, so if we solve that, 4x is greater than 50, so x is greater than, I think, 12.5. Should I agree with that? X is greater than 12.5. All right, that's kind of what they want you to know. All right. Now, I'm a little unhappy with this right here, and let me explain this to you. So, could X be 100?
No.
You said no. Tell me why. You're right. Shh. Well, come on. Why wouldn't it make sense?
Because if there were 100, then that would, the angles wouldn't match up.
Well, AB would be how big if X was 100, guys?
AB would be big.
I'm asking you, how much, though? 4 times 100 minus 10 is that hard.
390.
Would be 390. Right? Is it possible for that triangle to be 390?
No, because the two
Yeah,
angles
there
are
you
the
go. So again, they made kind of a mistake here because they didn't give you this length. But I feel like what their answer to me would be, well, that length could be anything then. All right? It could be, 350. And then if it were 350, then that would be okay. All right? Because they gave you an unknown, all they want is the fact that 4x minus 10 has to be greater than 40. That's what I want. All right? Everybody agrees, simple. All right, very easy. Yeah, she was like recording for something. I don't know. All right, here we go. So now, again, here we go for question number 6 now. Again, we're looking at the angles. All right, does this satisfy the side angle side? The answer is yes. So go ahead, Trey, tell me. So what do we got for the angle? I want you to write the comparison. It's loud. That's right. You would say that 33 is greater than 3x minus 3. But I would prefer to say, I'd rather write the fraction, or I'd rather write the variable first. Right? So we would say what? Go ahead.
3x minus 3 is less than 33.
Yes. 3x minus 3 would have to be less than 33. So now let's do a better job solving this. So that would be x has to be what? Less than what? Say it, please, someone. Less than 12. All right, I don't want to do all the math. X is less than 12, plus you ought to be able to do a two-step equation. Right? So x has to be less than 12. Right? So now it's the same principle as I was saying for the last problem. So could x be negative 1,000? No, because we don't know anything about negative angles yet. In the future, we will know about negative angles, but we don't know about negative angles right now. So technically, x can't be less than 12 because I need x to be greater than also what? 0. Listen to what I'm saying. x has to be greater than 0. Everybody with me on this? Right? No, that's what I'm saying. This angle, I should make myself more clear. Not x, but I need the angle to be what? I need the angle to be greater than 0. So I would also want you to write down that 3x minus 3 has to be what? Has to be greater than 0. All right? So in this case, x has to be greater than what? X has to be greater than 1. All right? Now, how do I write, and I know it's been a long time, how do I graph greater than 1 and less than 12? So we would say from 1 to 12. All right, that would be an interval notation that you'll be expected to know. All right, if you're greater than 1 and less than 12, that's how you write an interval notation from last year. The other way you can write it is this way. You would say x is, now again, remember you always write numbers from small to large, so you say it's less than 12 but greater than 1. Those are the options. Those will be the options. I'm listening.
Why couldn't it be like 0.1?
Well, that's greater than 1.
No, but like
Shh, no, you're not understanding what I'm saying. If x is greater than 1, a solution could be 0.1. Because if I plug 1 in, right, I get 3 minus 3. So x could be 1.1, which would make the angle 0.1. Okay, look right here. Last time. If x is greater than 1,
yeah.
Oh, I see.
if x is greater than 1, if I plug 1 in, I get 0 degrees.
Yeah.
We don't know about 0 degrees. So that's where my mistake was earlier. I was describing the angle and I accidentally said x. So x is not the angle. X is a description of the angle. All right?
So what you're saying here is it could be anything from 2 to 11.
Yes, but it could be 1.1 also.
Yeah.
Then why is it
Greater than 1. Right? Greater than 1. And so any number between 1 and 12 would work. Any number between 1 and 12. All right? So now, look at the next one. Here we go. All right, now it just looks as if we have, sometimes the figures just look a little bit harder, but they're not. All right? So the measure of BXA, all right? So I'm looking at BXA would be referring to this, and DXA would be referring to this. So I could easily say that the measure of BXA is right, less than.
Wait, why? Oh, sorry.
All right. Now let's take a look at side BC, which is this side over here, compared to what? Compared to DC right here. All right. Now again, here is where there's kind of some technicality, right? Because you have to understand that this satisfies the side angle side. But now it's just a matter of looking to say that one is obtuse and one is acute. I know I've told you not to assume anything, but honestly, that's the only way we can get this question. We have to know that this, oh, go ahead. Yes, that's exactly what we're saying. Because this right here, they're vertical angles, which means that this angle right here has to be greater than this angle right here. Very good, correct? And because that angle is greater, then we know what is true, that BC is greater than DC. Thank you very much. That was excellent. All right? So we have greater than on that. All right? Now, again, here we go on question number 3. All right, because we're going to compare STR. So I would identify STR, and then I would identify angle TRU right here. All right. Now, this is the one that starts to get things where it's mixed up a little bit. But what I want you to do, to me, what made it easy is when you highlight the angle that they're talking about. All right? So if you highlight this angle, right? And then you're going to highlight the other angle. You're looking at where they overlap. All right? And the overlap means that they are congruent. And then what you notice is you can see the 22 and the 22. So again, those are just my recommendations on how to see it better. All right, so now you can see that it satisfies the what? The side angle side. So now we can say the 30 compared to the what? 31. Everybody with me on this? So then the STR, you said it properly, is greater than TRU. All right. Let's look at number 4 now real quick. All right. So PQ must be what? Right. Right, again, that was kind of easy. All right, because again, it shared the common side and it wasn't twisted around at all. All right, now let's take a look at this now. All right, see if we can see something here. So it says in the figure, BA, BD, DC, and BE are all congruent. So what I want to do is I want to try to make that work. So BA, BD, BC, and BE are all congruent. And then it says AC, so AC is less than DE. So sometimes what I like to do, sounds kind of silly, is AC compared to DE. So we could say something like 7 and 10. All right, just so I can visualize. Yeah, I just made those numbers up so I could see it better. All right, you can make it whatever you want as long as it satisfies the conditions. All right, how does angle 1 compare to angle 3? Angle 3 is obviously what? Is obviously greater. Yeah, I don't see now. Again, angle 3 is greater than the measure of angle 1. Now again, the reason we would say that so quickly is because angle 2 is shared with what? Both of them. Exactly. So if we subtract out angle 2, right, we're subtracting out the same measure. So still this angle created there and that angle there, angle 2 plus 3 is greater than angle what? 1 plus 2. And then of course you just subtract out 2. Does everybody agree with me on this? That's very easy. All right, very easy.
Something like that on the test, but you can't really explain it. Just like
I don't really think. Did you not understand my
well,
explanation?
no, because I mean, yeah, you can explain it, but like it's not definite. Like,
Well,
you
but
don't have,
look,
like,
I should have said this. I should have said angle 2 plus angle 3 is greater than angle 1 plus angle 2. And then I just subtract.
Oh, yeah, okay.
And then I just subtract that out. You with me on that?
Yeah.
All right. Somebody else? All right. So again, I'm with you. Sometimes I can know it's true without being able to explain it. All right. And again, since there aren't really the proofs, then I think it really is kind of easy. All right. And those of you guys, listen, who haven't done as well as I want, now's your chance to get a good score. All right. Now, what I want you to do is, really all I have for you is just do those 4 problems. All right. And you should be done. All right. Very good. And then tomorrow I'll have a good review for the next 2 days. All right. And we're almost back on schedule.